Hi guys, so today we are solving this problem called coloring a border. Let's read it. You are given an m cross n integer matrix grid and three integers row, column, and color. Each value in the grid represents the color of the grid square at that location. Two squares are called adjacent if they are next to each other in any of the four directions. Two squares belong to the same connected components if they have the same color and they are adjacent. The border of a connected component is all the squares in the connected component that are either adjacent to a square, not in the component, or on the boundary of the grid. So this is something which is important to note, that like the connected component is either adjacent to a square that is not in the component or on the boundary of the grid, right? You should color the border of the connected components that contain the square grid row column with color, right? Return the final grid, right? So yeah, first of all, the connected components are defined either if they are on the border or in if it's in the middle of the matrix, then it should not have any of the sides having the color, right? So that's what it's written, that there are either adjacent, they are either adjacent to a square not in the component, right? So it's just next to a square which is not in the component, right? So that is the idea. For example, for the first one, if you see, the row and column is given to us. Row is 0 and column is 0, right? So we start from here and color is 3. We need to color with 3. So whatever, if you go from here to the next one, which is having the same color, and here to the next one, it is having the same color, which means that, yeah. And then from here, if you go down, it is not having the same color. So that's not part of the connected component. And this is entirely on the border of the matrix and it's part of the connected component. So here we'll color it and make it into something like 3, 3, 3, and 2. That will be the final matrix, and that is what we'll return, right? So that's the first example. If we see on the second or the third example here, so we have been given row and column as 1, 1. So we start from here and color is 2. So from here, if I go right, I have 1. Then here also I have 1. Here also I have 1. Here also I have 1. Here as well, 1, 1, 1. So basically the entire matrix is 1, right? But we need to, first of all, the connected components are only on the border. So all of these are on the border, so I can easily make them into colored as 2, right? But this guy, it's in the middle and it's actually adjacent to the color, right? So I can't make this one a colored component, right? So the final answer would be something like 2, 2, 2, 2, 2, 2, 2, and 2. And this one still remains as 1, right? And that's the final answer because this is actually not part of the connected component, border of the connected component. Border of a connected component says that it should be adjacent, that it should not be adjacent to a square that is part of the connected component, right? So or else it should be on the border, right? So these guys are on the border and it's adjacent to a like component which is having a same color, but it's still on the border. That's why it's still considered, right? So all of them are actually colored and the one in the middle is not colored, right? So the approach that we'll follow for this problem would be something like where I'll be, first of all, being aware about the connected component. So I'll run a DFS, simple DFS search, where I will just go through the array, like if I take the second example, 2, 3, 2, 2, I'll just go through the array and I'll just make sure the color that I have. So for the second example, the row is 0 and column is 1, right? So 0, 1, which is this color, right? So I'll go through the array and wherever that color is there, I'll just mark it as, some value. So for example, I'll mark it as int max, right? So this will be marked as int max, right? Int max, int max, and this one is also int max, right? So some values marked for those, right? And then I'll just go through the, like, so this will be, so I'll make sure that it is not in the same grid. So I'll create a duplicate grid where I'll mark this into the array. So I have int max, int max, int max 3, and int max, right? In my final answer, first of all, I'll make sure to color. So the color that I want to do is 3, right? So color is 3. So I'll make sure that the int max ones are on the border. So if you see here, all of them are on the border, right? So this, right? All of them are on the border. And the second thing that I want to make sure is that they don't like, so this one is actually not connected, right, to any of these. So actually it will never reach itself, right? This would never be reached anyway, right? If I do a DFS. Whereas all these will be reached because it's connected, right? So yeah, all of them will be colored to 3, and I also make sure that all of them are on the border, right? First thing. And also if it's not on the border, I'll make sure that any of the 4 adjacent sides do not have any connected components to it, right? So this one will be the final answer, right? So all of the ones which are int max, I'll make it into the color value, and I'll just return that as the grid, right? So that is the idea. So yeah, let's like just that will be the approach. We'll follow the DFS and we'll color all the connected components into the int max or certain values, right? And then I'll just again check that if all the int max are on the border, or if they are not on the border, I'll make sure that all the 4 directions have are not basically part of the connected components, right? So yeah, let's get to the coding part in order to understand this a bit better. Right. Let's get to the coding part. So first of all, I'll maintain a temporary grid, right? And then I'll just call the DFS function where I'll pass the temp, I'll pass the row and the column and the color that I want to do. So grid of row and column, right? And let's write the DFS function. So first of all, in the DFS function, what I'll have is this array, which is our grid. And then I'll have the row and I have the column and the color that I want to do. Right? And I'll check if row is less than 0 or column is less than 0 or row is greater than grid dot size, or like, sorry, not grid, here is temp. Actually, I'll just name it grid, right? So grid dot size -1, or column is greater than grid of 0 dot size -1, or grid of row and column is not equal to the color that we have provided, right? So if that's not the case, then I'll just return from there. Otherwise, I'll make sure that grid of row and column is equal to int max, and I'll just run the DFS on it. So grid row plus 1 and column and color, and DFS grid row column plus 1 color, DFS grid row -1 column and color, and DFS grid row and column -1 and color, right? That will be returned. So yeah, that is the idea. And then here, as I said, once I get all of the connected components as colored, then I'll just run a df, then I'll just run and iterate through the temp array, right? Grid 0 dot size -1 and j plus plus. And here, first of all, I'll check if I is equal to 0, or j is equal to 0, or I is equal to grid dot size -1, or j is equal to grid of 0 dot size -1. If that's the case, and if temp of I, j is equal to int max, right? So if it's a part of the connected component, then I'll just directly color it, right? I'll put the color, right? Else, if, right? Else in this case, if temp of ij is equal to int max, and all the 4 sides do not have any connected components. So I minus 1 j is not equal to int max, or right, or similarly the same stuff, which will be for I plus 1, right? And then similarly for j plus 1, and then similarly for j minus 1, right? In that case, yeah, in that case, if that's the case, then I'll color the grid for that index, right? And in the end, I just return the grid. That's what they want, right? So in the end, I just return the grid, right? So that is the idea. Let's run it to see if everything is working fine. Okay. And less than equal to, right? So that works. I submitted. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much.